So the pre-lesson, we've been on a good run. No pre-lessons necessary, but this one I think we got to take a little step back and look at some basic graphing skills before we dive into these sample problems. The title is called Systems of Inequalities in Two Variables. It sure doesn't sound like you need to do any graphing, but it's all about graphing with a little bit of an inequality thing thrown in there. So here at the high school I teach at, we just beat them up big time with graphing lines and parabolas. The only thing is, what the heck are these? And this is something we don't introduce to our Algebra 2 students anymore because we went to trimesters, and so it got cut. And so we got to make up some time for that. But here we go. What does y equal 2 look like? Well, I tell my students, that's the biggest clue, because it's going to cross the y-axis right at 2. Okay? Now, how about x equals -3? Well, it's going to cross the x-axis right at -3. And so those are the shortcut methods to how to graph those types of lines. Those are linear equations, but they're a little tricky, so easy that they're hard sort of thing. And here comes your classic y equals mx plus b. Obviously, I put it in the simplest form, so 3, 4, 5, 6, dot, up 2, right 1, bing, and then you're off to the races. Again, is that the only way to graph it? No, but it's the simplest, I think, okay? Now we're to our parabolas. Now, I want you to notice something. These are to the first power. These are to the first power. That's why they're called linear equations, lines. Quadratics, you got one of the variables squared, one of them's to the first. One of your variables squared, one of them's to the first. So this is just your basic parabola. It looks like this. We've done a lot of these, so this should not be like, whoa, what are you talking about at this point? All you do with this one is move the previous one, because it's the exact same thing, up 2. So this guy would come up 2, so I'll just make that red, and then so you just draw the same thing up 2. Okay, not too big of a deal at this point in pre-calc B. You should have a real good understanding of graphing. All right, now to these rascals. Now you can always go to desmos.com to check anything that I say to make sure if I'm off my rocker or, oh, that's mathematically correct. So, but just so you know, the general equation, I did say over here, like y equals mx plus b, is the generic equation for any line. The generic equation for any parabola, if you want me to get fancy, is y equals ax minus h squared plus k. Are these k? Anyways, that's kind of the generic form of any parabola. Now this, the generic form of any circle, there I just gave it away, is x squared plus y squared equals r squared. What do you suppose the letter r stands for? Radius. So, just so you know, this right here and this right here is essentially telling you there is no shift of the center of the circle. In other words, because this doesn't look like this, we know the center of our circle is 0, 0. Now I'm going to make this one red. Now if r squared equals 9, then doesn't that tell us that our radius is 3? So all you do is go from your center out 3, up 3, left 3, down 3, connect the dots to the best of your ability, and there it is. So what's the difference between this black one and the one that I just did in red? Well, the center is going to shift right 2, so right 2, and then down 3. So right 2, down 3, and now it's kind of like, there's your new y-axis, there's your new x-axis. That's the way I look at it. It's like crosshairs. You ever look through a scope? You just move the crosshairs, right and down. Now, the square root of 9 is going to give me my radius still, so that didn't change. So I just need to go right 3, 1, 2, 3, put a dot, up 3, which would be here, left 3, which would be right here, down 3, which would be right about there, and then just draw your circle. So it's the same circle shifted right 2, down 3. Check it out on decimals.com if you want to mess around with some graphing.